In this video, we are going to discuss sorting technique. What is a material sorting? Actually, material sorting means separating materials based on differences in their physical or electrical properties. For example, physical and electrical properties. Okay. For example, if we have a group of similar looking pipes or fittings. Okay, so sorting can help us quickly identify whether one item is different from others. This is very useful in fabrication shops, warehouses, shutdown jobs, and site material verification activities. But sort is mostly a qualitative method. This is a qualitative method. Okay, that means it gives a comparative answer, not a complete chemical analysis. For example, it may tell us this item is different from the standard sample. Okay, but it may not tell us this is exactly SS316 with this percentage of chromium and nickel and molybdenum. So sorting is useful, but it has limits. The first one is thermoelectric sorting. The first method shown in this slide is thermoelectric sorting. So it works based on feedback effect. Okay, when the two different metals are connected and one junction is heated, a small voltage is produced. So this voltage depends on material type. It depends on material type. Okay. In thermoelectric sorting, the instrument uses a heated probe and cold probe. Okay. When these probes touch the metal surface, a small voltage in millivolts is generated. Different alloys may produce different voltage values. So, by comparing the voltage from the test material with the known standard, we can identify whether the material is similar or different. Okay, so now let us look at diagram 1. This diagram shows a thermoelectric sorting principle. At the bottom, we have the metal specimen being tested. On the left side, there is the hot probe. This is a hot probe and this is a cold probe. Okay. The hot probe heats one point of metal here, while the other probe remains cooler. Because of this temperature difference, a small voltage is generated. So this voltage measures millivolts, shown as MV in the diagram. The measured voltage depends on the alloy being tested. For example, one alloy may give a higher millivolt reading and another alloy may give a lower millivolt reading. Okay, then we compare this reading with the known reference material or standard sample. The important note in this diagram is compared with known standards. That means qualitative sort, not exact grade ID. Okay, this means thermoelectric sorting is useful for comparing materials, but it should not be used as the final method for exact grade confirmation when the result is doubtful. Okay, now the other sorting techniques. The other sorting techniques are, apart from thermoelectric sorting, here eddy current sorting, magnetic sorting and triboelectric sorting. Let us understand one by one briefly. First one is eddy current sorting. Eddy current sorting works based on changes in electrical conductivity, and magnetic permeability. Okay. When an alternating current coil is brought near a metal, eddy currents are induced in the material. Different materials respond differently based on their conductivity and permeability. So, eddy current sorting can help separate materials with different electrical properties. It is useful for quick comparison, but again, it does not give full chemical composition. Okay. The next is magnetic sorting. Magnetic sorting is based on magnetic behavior. For example, ferritic steels and carbon steels are generally magnetic, and austenitic stainless steels are generally non-magnetic or weakly magnetic. Okay, so magnetic sorting can help separate ferritic materials from austenitic materials. Okay, austenitic material, and carbon steels from austenitic stainless steel. Magnetic items from non-magnetic items. But magnetic response alone cannot identify the exact grade. For example, many different ferritic steels may be magnetic. So, magnetic sorting is only a screening method. Okay. The next one is triboelectric. Triboelectric sorting works based on a surface charge or friction related response. Okay. Friction related response. And it is also connected with ferrite meter concept. Ferrite meter is commonly used to measure ferrite content, especially in weld metal and stainless steel applications. This can be useful where ferrite level is important, but it is not a complete PMI chemical analysis method. Okay. The next is qualitative nature of sorting. Here, qualitative. The answer is this different, not exact grade. Okay. So, sorting techniques are not usually used to issue a full material grade certificate. They are used for fast checking and material segregation and finding mixed materials and flagging suspect parts and deciding whether PMI is recovered. For example, if a batch of stainless steel fittings is expected to be the same grade, sorting can quickly identify one fitting that behaves differently. That item can then be tested by a definitive method such as XRF, OES, and LIBS or laboratory method. And the next topic is good applications of sorting. Sorting methods are good for fast field screening. They are useful when we have many items to check quickly. For example, large quantity of bolts and mixed fittings and warehouse material verifications, shutdown replacement materials, and segregation of similar looking materials, incoming inspection, and identifying suspect components. So sorting can save time because it quickly identifies items that are different from the reference group. Okay. Now let us look at diagram 2. This diagram summarizes the sorting methods and their limitations. At the top of the 4 sorting methods are shown. First one is thermoelectric, based on seeback voltage. Second one is eddy current, based on conductivity change. Third one is magnetic, based on separate ferritic and austenitic materials. The next one is triboelectric, so related to ferrite meter type sorting. So below that diagram shows the good side of sorting. Sorting is good for fast field separation, lagging is suspect part, and simple this versus that sorting. This means sorting is very useful when we only need a quick comparison. But the diagram also shows the limitations. Okay. So sorting is a qualitative only. It may be weak on less than 5% chromium plus and austenitic stainless steel. This means sorting may not reliably separate some alloys when the difference between them is small or when their physical properties are too similar. Okay. So sorting is useful for quick screening, but it is not a final grade identification method. Next is limits of sorting. So sorting techniques have limitations. Here, weak on 5% chromium alloy and austenitic stainless steel. Why? Why? Because some alloys may have very close physical properties. They are electrical and magnetic, thermoelectric response may be too similar. For example, two low alloy steels with a small composition difference may not show a strong sorting differences. Similarly, many austenitic stainless steels may behave similarly in some sorting methods. So, the inspector must not overtrust sorting results. If the result is unclear, doubtful, or critical, confirm it using a definitive PMI method. Okay, to confirm, you can use definitive PMI.
Thank you for watching this video. Please follow our page for more upcoming videos.